Alright, back doing some LeetCode stuff. I actually switched down to the medium collection. I watched a video from the tech lead, and he made a comment that going through the hard collection on LeetCode actually wasn't as worth it, just because they're so involved, and that going through the medium collection is probably a more realistic expectation of what to see in an interview. So I don't know. I'll take it. Um, I'll switch it up instead of doing graphs or sorting. I kind of want to try a linked list one, see what that looks like. So let's do add two numbers. You're given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their nodes contains a single digit. Add the two numbers and return the sum as a linked list. Okay. Oh, I see. Wait, maybe I don't see. 342 plus. Oh, so it'd be 7. I think you add downwards, but it's backwards. Is that right? Oh, this is weird. Okay. Definition. Okay, so they made a little class for us for a list node. So it's 807. Oh, 7, 10, 8. Okay. Is that it? Do you just do that and then is that it? You just add these up and then reverse it? If so, that's not too bad. I think that's it. Do not contain any leading zero except the number 0 itself. What? Okay. Are they of equal length? No, just two non-empty ones. Alright. So for this one, let's see. What would you do? You'll have to have a number that carries. So you would traverse it until you hit the end, I guess. And then, yeah, so add these two, and then you'd have to keep track of the carry. And you'd probably have a while list while L2 next is not equal to none, and L1 dot next is not equal to none. Then you keep traversing and add these two numbers, have a variable that's the carry, and then you add in the carry each time. You add in the numbers and revert the carry back to 0 unless unless it's greater than 10, I guess. Are each numbers, is it one single number in each? Is val val is between 1 and 9, so I know that carry is only ever going to equal 1 because 9 plus 9 is 18, so that's good to know. And I think you'd probably just carry that out until you hit the end and then revert it. Is that right? So for example, with this, you do 2 plus 5, there's no carry. You have 7, 4 plus 6, there's a carry because divided by 10 is greater than 1. Is that how you would know it? You could do divide by 10. If it's greater than 1, then carry equals true. And you would want to do, the number would be 10 mod 10. Or sorry, the sum mod 10 if it's a carry. And that would give us 0 because 4 plus 6 is 10. Mod 10 is 0. Carry is 1. 3 plus 4 if carry, add 1, 8. I think that's decent. At least a decent start. Doesn't have any leading zeros. Okay. go ahead and see what this looks like. So I know I'm going to need a carry while L1 dot next okay, I'll need to start. Let's do number 1 is equal to L1 and number 2 is equal to L2. Or I guess this is a node. And while node 1 dot next is not equal to none and node 2 dot next is not equal to none. That means we'll go until we've hit the end of both lists. We want to get the values. Node 1 value is equal to node 1 dot val. Same with, whoops. Do I even need this? Is this even gonna, I don't think that, all that does is add memory usage, so I don't think that's really, I don't think that's completely relevant to have. I need to add these up. Let's see. Maybe I will need these. If node 1 dot val it defaults to 0, and if next, I would traverse it using next. So what I'm looking for here, if node 1 value, or if next is none, if node 1 is not equal to none, I'll just go until they are none. If node 1 dot not equal to none, else 0. Yeah. So what this is pretty much saying is if it's none, that means we hit the end of the list. And it should be 0. But if it's not none, then we should just take its value, because this would fail if it was none. None doesn't have a type of val. So that gives us the 0. And then we want to add those up. Sum is equal to this plus node 2 value. And then to find the carry is equal to true if sum divided by 10 is greater than 1. Point 0. Do I have to make it a float? I'll make it a float either way. If it's greater than 1.0, it should be true, else it'll be false, and the value for that place, so place value is equal to sum mod 10. Is that Python, is that the right operator? Is it? Yeah, okay. So that's the place value. Is the output supposed to be a linked list or just an array, or what do I return? To non-empty list, digits return in reverse order. Well, gonna go ahead and guess that I'm supposed to return a linked list. Result is equal to list node. Is it new? No, I think it's just list node. The value, will start it at 0, and next should be none. Oh, I guess we could just do that here. So result. Yeah, I'll want to keep track of that first. So I'll do yeah, I want to keep track of it. So result dot next. I'm just trying to think of how I want to program this out, because I need to keep track of the list nodes, and they'll start until they go to next, and I don't want the last one to exist. So the first one, the first one, yeah, we want to take result, and then we want to add a list node onto it. So this would be our first value, our first node, and well, here I'll do this. If result is none, then we'll do something special. So on the first time it goes through, result is equal to list node val is equal to place value, and next we'll leave as none. If it's not the first time, which means result is not none, result would be a list node, then result dot next current, we'll do current node is equal to none. We'll have current node equal to result current node. We want the current node to turn into next for the previous current node. So new node is equal to list node val equals place value. Next we'll leave as none, and then we want current node yeah, this is, I pretty much just need to initialize all this, the current node and the result. So I'll keep pointers towards first element in list, last, I'll just call it last, list. We'll have current node and last node. Last node dot next would be the new node, and then the last node would return to point at the new node, and I wouldn't need the result. So does that sound right? So going through this the first time, result would be none, so we would change result into being the list node, and the last node would also be pointing at result because that's the first element. And then in the new node, after result is set, it shouldn't be none anymore. So it would go down here. So we would have new node. We would create a new node with the place value, and then the last node would be the previously created one. The first time around it would be result, and its next would be the new node, and then we transition the last node to point at the new node. That sounds right. One thing we have to do here is the place value if carry. Oh, I need to do that beforehand, right? Oh, really? You want to let me do that? Okay. Well, let me do a little shortcut. So the sum is this, the place value is this. If carry was true from the last one, if it was true from the last one, then we want to do place value plus equals 1. So this accounts for the carry of the last iteration, and then over here, carry will either be true if we have another carry. Ooh, we need to do that after. We need to do that with place value. Is that right? So this needs to go after sum, not place value. So we'll make the sum with the nodes, and if there was a carry from the last time around, then we'll add one onto the sum. The place value would be mod 10 of the sum, including the carry, and then the new carry will be based off of the place value or the sum. Yeah, either way. If it's greater than 1, carry is true. Sorry, if sum divided by 10 is greater than 1, carry is true, otherwise it's false. So if it's less than or equal to 10, because if it's carry would be true if the sum is greater than or equal to 10. I could just do that. That's much easier. So the carry is true if the sum is greater than or equal to 10 because the mod would take care of that. If it was 10, that means that place value is 0 and we would need to carry the next one. If it's less than 10, then it's false. And the reason I'm only matching for this and only doing this mod 10 is because I know that the node val has to be less than or equal to 9. So the max value for a node or two nodes being added up. Ooh, I wonder if you could get 20. It would happen in this case. So I'll have to go through this real quick. Would be 9. So if you add two nodes up, 9 and 9, it's 18, and you carry that, you would get 18 plus 1 is 19. Carry 1 is 18 is 9. So no, you could never get a carry more than 1. So I'm safe in this logic here. So I know that sum will never be sum will never be greater than 19. So place value, the max can be is 9, and then carry can only ever happen once, so I'm safe only doing the plus equals 1. If the result is none, so this is on the first time around, on first iteration, then the result becomes a brand new list node. The last node is the same as the result, every other iteration, we're going to create a new node, and then we're going to make the last node's next point to the new node, and the last node turn into the new node. And then I guess at the end, we'll return result. That is assuming that they want a linked list as output. Okay. Node 1. Okay, and node 1 and node 2, those need to change. Because right now, they're not going next. So, yeah, I need to change those guys around. So node 1, at the very end of all this, of this while loop, node 1 is equal to node 1 dot next. That is if node 1 is not none, because I could hit none, then I'll transition it. Oops. And if node 2 is not none, I will transition it. So that'll push them through. So if node 1.next is none, that means we hit the end of the list, right? The default is none. And that's fine. If it hits none, we don't do anything. If node 1.val is only, this only gets populated if node 1 is equal to none. Otherwise, it's 0. And I'd have to, let's ensure that that is correct. So we do 9 and 9 is 18, carry the 1. 9 and 9 is 18, carry the 1. 9 and 9 is 18, carry the 1. 9 is 18, carry the 1. Then we're on its own, so it's 9 plus the carry is 10. 9 plus the carry is 10. 9 plus the carry is 10. 9 plus the carry is 10, I guess, and then 1. So if there is a carry at the end, we're going to have to add that in. So if we add that in, it has to be, well, node 1 is not equal to none, node 2 is not equal to none, and not carry. Where's carry? Okay. So if carry is set to true, even if we're at the end of both of these nodes, we have to add the 1 in. So these would both be 0. Sum would be 0. If carry, that would be true, then sum is equal to 1. Place value would be equal to 1. Carry would be equal to false. Results, it would be down here probably. New node would be set to be 1, and it would transition, it would push through, and then if, and then these don't necessarily stop the while loop. So, this is outside the while loop. That's not right. There we go. Yeah, those need to be in the while loop. Okay. Let's go ahead and run this code. I think those were a decent look at it. Okay. Looks like we cut one off. What happened to our 8? Let's do... Let's see. This doesn't need to be part of the class. Def print list. List start, and we'll do while list start is while node is not none. let's do dot append node dot val node is equal to node dot next. And let's print this list. I'm pretty sure that's all they're doing to get this down here. I'm guessing. So we'll print the list and then we'll do a print for, let's see, what other information could we use in here? Place value maybe? We could use the place value. We could use carry. And we'll go ahead and just leave it like that. Get some information here. All right. We have should these be ORs? Yeah, I think that's why. Node 1 is not none, or node 2 is not none, or carry. Yeah, I don't think I situated those correctly. Or carry, because carry would have been true, so it should have pushed through with all those. Still, something doesn't necessarily seem right. Oh my. Well, we hit an infinite loop. That's fun. So it did get to 8. So carry was false, but it still kept going. So while node 1 is not equal to none, or node 2 is not equal to none, or carry, not carry. So this needs to be true in order for the loop to run again. So if node 1 has a value, we want to run it again. If node 2 has a value, we want to run it again. If carry has a value, we want to run it again. So if node 1 is none, and node 2 is none, and carry is false, then we want to stop it. So that, yeah, I'm just got my Boolean logic messed up there. And there we go. Okay. Let's go ahead and submit this. Oh, it was accepted. Well, there you go. That feels good. Feels nice when you don't have to go through and mess with all the extra stuff. It doesn't seem like I did it extremely quickly. I only beat a quarter of the submissions. I did beat almost half of the submissions as far as memory distribution goes, but I'm sure there are things in here that I could trim down on. Yeah, but nothing that's blatantly apparent to me. I'd have to look a little further, and that's not what I'm trying to do today. So just trying to get through some examples. So thanks for watching, and I will see you in the next one.